Hi guys, welcome to the Nomenclature video. The way that we name organic chemistry compounds is using the Iupac Rules. The first step is to identify the parent chain. You need to find the longest consecutive chain in the molecule, and that's the parent name. The second step is to identify if you have any stereochemistry in the molecule and where that stereochemistry happens. The third step is to look and see if you have any unsaturation in your molecule, double bonds, triple bonds, and then again, where are those located? The fourth is to identify any functional groups that you have and the locations of those. And fifth, we are going to identify and name the substituents that are on the molecule and their locations. And finally, after we put our di, tri, tetra prefixes in and put them in alphabetical order and put them before the parent name, we put it all together in that last step. Every Iupac name is organized in the manner shown below. At the very beginning of the name is the stereochemistry, followed by the substituents and their locants. The center is going to be your parent, so that's the longest carbon chain. Then we are going to indicate any unsaturation in the molecule. And finally, the suffix at the end is going to talk about the primary functional group of that molecule. Stereoisomerism, that first category, we will learn in the next chapter, but everything else you'll be required to know for this chapter. Okay, let's learn about this functional group and how we get the right suffix at the end of our compound name.
We talked about in class that if you have a functional group in a molecule and you're naming it, that the functional group gets the suffix. I'm going to systematically walk through all of the functional groups that we could have, and we'll talk about what the suffix will be. We'll follow that conversation up with priorities, and that is in case you have multiple functional groups in the same molecule, you'll know which one gets the suffix and then which one becomes the substituent. And so this is a little bit awkward because we're going to be working from the bottom up. So the handout is posted in Moodle. We're going to start at the bottom of the page and work our way up. And then I hope you'll see at the end that this makes more sense. So if we have a triple bond in our molecule, when we're naming with the suffix, what we do is we take off the ane of the alkane name and we replace it with, for a triple bond, it is YNE. And so if you have a 2-carbon molecule with a triple bond, that becomes ethyne. The column right here is going to be the suffix, and the column right here is going to be the example. If you have a double bond, we take off the ANE and we replace it with ENE. And so that becomes ethene. So if we have a nitrogen in our compound in the form of anamine, we are going to take off the ANE and replace it with YL-amine, methanamine, or methylamine, shown here. If we have a sulfur in the compound, we're going to leave the ANE here and add to it thiol. So this is going to be methanethiol. I've also heard the amine called methanamine, and so I would accept that answer as well. If we have an alcohol on our compound, we take the E off of the alkane name and replace it with OL. So this is methanol. If we have a ketone in our compound, we take off the E and we replace it with an ONE, and so that becomes propanone. If we have an aldehyde in our compound, we take off the E in the alkane name and replace it with AL. So this is ethanal. If you have a nitrile in our compound, we are going to take off the E in our alkane name and add O-nitrile. So this would become ethanonitrile. So in this case, look at the bottom. I'll explain the top in just a second. If we have an amide in our molecule, so we're going to look at the bottom suffix. We are going to take off the E in our alkane name and name it ethanamide. I will describe the top entry here in just a moment. If you have an acid halide, which is a carbonyl next to a halogen, we are going to take off the E in our alkane name and add oil halide. For the example shown here, we have a chlorine, so it's going to be ethanoyl chloride. So if we have an ester in our compound, remember our ester is an OR group. group. And so we have to describe both that it is an ester and we have to describe what group is on the oxygen. We're going to take off the E in the alkane name and replace it with O8. So in this case, because we have 2 carbons here, that's ethane. So it's going to be ethanoate. And then because this is a methyl group right here, we're going to put methyl in front. So the formal name for that ester is going to be methyl ethanoate. So methyl comes from the group that's on the oxygen, and ethane or ethanoate comes from the fact that there's 2 carbons here. We do not have to name sulfonic acid. And if we get to the very top of our list, the highest priority is the carboxylic acid. So if we have a carboxylic acid in our molecule, we're going to replace the E in our alkane with oic acid.
So this becomes
ethanoic acid. Okay, so now we've learned how to add the suffix if we have one of those functional groups in our molecule. It becomes oic acid, O8, oil chloride, amide, nitrile, Al, ONE, OL, thiol, amine, ene, ine. So in these 2 cases, we replace the ANE with the ENE and the YNE. And then moving up the list, we take off the E and we add the suffix. This is the order of priority of who gets the suffix. So the most important functional group, the highest priority functional group, is the carboxylic acid.
I wanted to also point out that
the first 7 things on this list all are going to be found at the end of the molecule. And so because they're at the end of the molecule, the carbonyl carbon, this one right here in all cases, becomes carbon number 1. And so that's a little bit easier because we know that's going to be carbon number 1. Okay, so in terms of priority, if you have more than one group in your compound, carboxylic acid wins. So the ending of your name is going to be oic acid. And then you have to use a prefix to describe the other functional group that's on there.
In terms of this additional functional group, you will also have to put the locant and the prefix to describe where and what else is in the molecule.
The primary ones that I would like you to know are if you have a carboxylic acid and a nitrile in the same compound.
Your suffix will be oic acid.
Your prefix is going to be cyano for a nitrile, formyl for an aldehyde, oxo for a ketone, hydroxy for an alcohol, mercapto for a thiol, and amino for an amine. Those are the names that we are going to use if there is more than one functional group in the molecule and the other one wins. You do not have to worry about this one or this one. We have had the situation where there's multiple carboxylic acids, and so the second carboxylic acid would be carboxy. I told you that I would come back to what this top suffix means, and that happens if your functional group is outside of the main chain, and that primarily is going to happen when we have a carboxylic acid that is outside of the main chain. So this is cyclohexane with the carboxylic acid on the outside. So this would be called cyclohexane carboxylic acid. So it just tells you that there is a functional group outside of the main chain. And same with carboxamide. These 2 names circled in green are if you have a functional group that's outside of the main parent chain. And same with aldehyde. Carbaldehyde would go if you had a cyclohexane with an aldehyde out here. That would be cyclohexane carbaldehyde. Whereas if you had the straight chain with the aldehyde on the end, that is just going to be hexanal. So the way that I think about these ones circled in green is if there's an additional carbon on your molecule compared to what the parent name is, then we're going to need to use that carbaldehyde, carboxylamide, and carboxylic acid. So now if we want to talk just a little bit more about alkenes and alkynes, if you have a molecule where you have an OH and an alkene in the molecule, the OH wins priority. And so the ending of our name is definitely going to be OL. And that is going to be carbon number 1 always. And so we have to talk about numbering our carbon chain. So we're going to number it starting here So it's 1 through 5 in this direction. And our double bond, when we talk about where the double bond is, we have to talk about where the double bond starts. And so here we have pentane, but we have an alcohol, so it's pentanol. And so if we want to talk about now that there's a double bond in there, we are going to say pent 4-ene, because 4 is where the double bond starts, 1-all. And remember, I told you dashes go in between when you have a letter next to a number. And if you do have two numbers next to each other, there's a comma. So this one is going to be pent 4-ene 1-all. So whatever functional group gets the suffix also gets the lowest number when we're numbering the carbons. And so if we go over to the more simple one here, we have a total carbon chain of 5, so that's pentane. And we have a double bond that starts at carbon 1. And so we're going to have 1 pentene or pent 1-ene. And if we go down to the alkyne examples, we'll start on the right over here. We have a total carbon chain of 5. So our parent chain is going to be pentane, but we do have a triple bond that starts at carbon 2. And so this is going to be 2-pentyne or pent-2-ine. And if we move over to the more complicated YNE alkyne, we have an amine in the compound and a triple bond that starts at carbon 2. The amine has highest priority, so that gets the suffix. So and there's 4 carbons, so it's going to be butane, but it's going to be butanamine or butylamine. But because we have the alkyne, we insert 2-ine. The total name for that compound is going to be but-2-ine 1-amine. And so if we move forward and think about if you have an alkene and an alkyne, both of those functional groups in the same molecule, then we're going to talk about which one gets priority. So the first thing we have to do is number it so that both have the lowest number. And the second one is we're going to name it alphabetically. So if we go through these two examples, okay, in this first example right here, we have an alkyne starting at carbon 1 and an alkene starting at carbon 3. And so if we were going to name this, the YNE gets priority and gets the suffix because it has the lowest number. And so we have pent 3-ene 1-ine. So we do not want to number it in the other direction, 1, 2, 3, 4, 5 in that direction, because then our numbers would be 2 and 4 instead of 3 and 1. So 3 and 1 wins. It's also not 1-ine 3-ene because ene comes before ine alphabetically. So it's pent 3-ene 1-ine. And if we look at our second example, it's tied. We could either number it so that the ene gets carbon 1 or the ine gets carbon number 1. And because ene is alphabetical, that one wins. So it's going to be pent 1-ene 4-ine. And then if I can just quickly introduce you to a list of functional groups that never get the suffix. So these are only ever going to get a prefix. And that is all of the halogens, bromo, chloro, fluoro, iodo, and the
Ether functional group
called alkoxy. And then we don't really talk about this group right now, but that's azeto. And then if you have an NO2 group, it's going to be nitro. And so here are some examples of how we can name those. And there you have it. Now you know all of the suffixes for all of the functional groups. You know the priority for which one gets the suffix. And then you've been introduced to the names of the functional groups if they are a substituent, in which case they become a prefix. The only way to do this and to know this and to understand this is to practice. So I highly recommend that you spend some time practicing these functional groups and naming these compounds.
This template shown here is very helpful in learning and practicing this nomenclature.